prayerful for too. Obviously, the pandemic is still raging on, and we want to be mindful of all those who have been adversely affected. But I wanted to offer up a special prayer today. I found out yesterday about a friend who works at the bike shop that got into an accident. His name's Mike. And so we want to remember Mike and his family while he's going through his recovery. He definitely is in need of our prayers. So y'all bow your heads and let us remember that we're in the holy presence of God. Father, we thank you for this day. We thank you for the nice, cool, crisp morning that we have before us. We thank you for the opportunity to get up and come to school safely. God, I thank you for good friends and things like cinnamon rolls. And Lord, we are so blessed. We live a good, charmed life. And God, we know that we face challenges in this life. So I pray that we would turn to you for help during these challenging times. Special prayer we offer up on behalf of Brother David today. Let him continue with his successful battle through cancer. Pray that you bless our CBHS sophomore Bo Branyan and his family and the medical team at St. Jude, that they would find a cure for his rare disease. And God, we pray a special prayer on behalf of Mike today. God, we know that he was in an accident on the highway and that his life has now changed. And so, God, I pray that you would work a miracle through him and that you would comfort him and his family, God, during this tough time. Lord, as we go throughout our school day today, may we strive to put forth an effort that pleases you. And may we give our best effort, not just to do what is right, God, but to do so joyfully, to have good cheer in our heart, knowing that we're serving you, our perfect and loving God. Please watch over us as we go throughout class to class, as we interact with one another, and as we go to the weekend, Lord, may we find peace, may we find rest, and may we love you with all our hearts, souls, and minds and strengths. We pray this in Jesus' holy name, amen. St. John Baptist de La Salle, live Jesus in our hearts. All right, my dudes, y'all have a seat. I do have on the screen here in front of you a warm-up that I pulled from just an ACT practice question. And it is, let's see, I got what I want there on the screen. It is a proportion. And we talked, at least I talked with my ninth graders on Wednesday, and I recorded that. And then yesterday, you had another screencast. So you had a couple of screencasts this week talking about solving equations that involve fractions, right? So this is an example, not just where you're asked to solve an equation, right? It's j minus k over k equals 3 over 8. That's a proportion, right? Do you remember how we said to solve a proportion? Channel your inner fruit ninja and cross multiply. Okay, y'all, did you watch the screencasts at all? We talked about. What's my favorite? This is a good little quiz question if you watch the video. What's my favorite fruit on the game Fruit Ninja? The pomegranate. That's where you could have just guessed that, I guess, but I think you probably watched Fall and learned that. Good little factoid. Anywho, yeah, we're going to cross multiply, but look, we're not trying to figure out, well, j equals some number or k equals some number. We want to know what is the expression j over k, all right? So this is typical ACT curveballage, where it's not just, hey, solve this rando equation. It's take this equation and solve it in a particular way. So your goal is to get j over k by itself, okay? Chew on that for about a minute. Usually on the ACT, you have about a minute per question for an average question like this. About 10 more seconds, and we'll discuss. All right. Now, the first thing right out of the gate, at least try right? You think, okay, there's a proportion. I'll try cross multiply and see what happens. So we do that, and we get 8j minus 8k because of what property? Distributive property, fabulous. And then that equals 3k. All right. Now the trick is to combine what? Yeah, combine like terms. Well, what would I do to both sides to combine like terms? Yeah, we're going to get 11k equals 8j. Now, what's our goal? What am I trying to get on one side of the equal sign? J over k. So right now, j is on the left, and if he's going to be on the top of said fraction, then I'm going to divide both sides by k. But what I don't want on the top of that fraction is an 8. So I need to get it over to the other side. So I'm going to divide both sides by 8k. This is a little 2-for-1 special. You could do this step, split it up and do it separately, but I'm going to divide both sides by 8k. All right. What happens on the left is that the 8 cancels out. What happens on the right is that the k cancels out, and I'm left with j over k equals 11 over 8. And that's option C, right down there at the bottom. Okay. Paul. Say that one more time, Paul. So are you talking when we originally cross multiply? Okay, so cross multiplying, what that is in essence doing, fabulous question, you know, because what we said was, hey, just multiply the extremes and the means. Multiply the bottom left, top right, multiply the top left, bottom right, and then it produces magically some new equation. No, it's not magic. What we're in essence doing, and I'll zoom in here in the original problem, what we're in essence doing is sort of like what we did a moment ago, where we perform an operation on the left side and we perform a similar operation on the right side. What I'm doing over here is I'm saying let's multiply both sides by 8, okay? Because I want to kill off the fractions. We talked about that in one of our videos, right? Where we said to kill off the fractions, you multiply by the LCD, okay? So I multiply it, if you wanted to one step it here, multiply both sides by 8. That fraction goes away, and we're left with 3 equals 8 quantity j minus k over k. And then we say, well, dadgummit, there's still a fraction over there. Let me multiply now both sides by k. And this will be the equivalent, I used the analogy in class earlier this week, of sniping them off. You know, picking them off one at a time if you play like Call of Duty and stuff. Do 8th graders play Call of Duty? Okay. So anyway, that kind of in essence is what we would be doing when we say, you know, cross multiply. We're really just multiplying by the LCD. And if I had wanted to go from the top down to the bottom, instead of multiplying everything by 8, I could have multiplied everything by 8k. In other words, multiplying by the LCD there. Great question, Paul. Does that make sense how I answer? Okay. So we feel fully, properly warmed up. We feel good about that? Okay. Again, ACT loves to ask, and not that y'all are taking the ACT anytime soon, but they love to ask questions like they didn't just come out and say, hey, here's a proportion, 2 over x equals 3 over 7. They didn't just come out and say, hey, solve this proportion. Now, they might on like one of the earlier problems, right? The ACT has how many math questions in it? Do y'all know that? 60. You got 60 math questions. And usually what they'll do is they'll break up the 60 questions into the first 20, the second 20, and then the third 20. And it goes, typically it goes easy, medium, and hard. You know what I'm saying? Did y'all know that already? Okay, some of you did, some of you didn't. Well, anyway, like a problem like in orange right there, that would fit in the easy category. That'd be one of the first 20 questions on the ACT. Okay, the problem that we just worked out, right, will probably be in the middle section. So they like to throw a little deuce at you. They like to throw a little curveball your way and say, yeah, we could ask him, hey, how do you solve this proportion, right? 14 over 3, I think is what we'd get. And that would go in the easy category. But then they'll say, hey, better yet, solve this proportion in a particular way where we put maybe a couple of variables there. And it's checking to see, well, does he know how to cross multiply? But then also, does he know how to combine like terms and get the set the problem up the way that he wants to. So as you, over the next 2-3 years, as you kind of prepare mentally for college entrance exams, you kind of need to know little tricks of the trade like that. Okay. Now, talk to me honestly. You guys, this is the tree of trust. right? Talk to me honestly. Anybody actually try and watch both videos and do the Delta Math assignment that I put up? No? Okay. All right, so would it be much of a stretch for me to, let's see here. Would it be much of a stretch for me to ask you maybe to try and solve one of these on your own? Do you know how to do this yet, in other words? I feel like you do. Some of you do, some of you don't. Why don't you take a stab at this one? This is just a typical problem from the last section. I can't move on. I can't move on to section 7.5 until I know that you guys are confident in your ability to solve this. And not to be all preachy and whatnot, but we need to do a better job, right, of staying on top of our lessons. If I'm out on a Thursday at senior retreat, right, I was hanging out with Jake's older brother yesterday all day. If I'm out on a senior retreat, you need to pretend like you do have class. Now, you ain't got to get up early in the morning and watch it, you know, but you do need to watch our class. And I take time to put it on YouTube, not for my health, not for my, so that you can smash that like button and get all these subscribers. But I put it on there so that you can keep up to date with what's going on. James, did I see your hand up? No? Tiago?
I didn't know there were two videos. I thought there was.
You watched one of them? Which one did y'all watch, the first or the second?
I watched the second. I watched the first one. I watched the 17-minute long one.
I don't remember how long each of them were. Okay, gotcha. Well, look. Okay, so just taking kind of a time out here. Like this lesson, lesson 7.4. Like some of the early examples were pretty straightforward and easy. That was the first video, and then some of the harder examples were the second video. So if you watch the second video, you got some of the harder examples, and that's probably of the two videos the more helpful one. If you only watch the first video, then just go home this weekend and watch the second one. Okay. And then as far as like the Delta Math goes, man, that's our practice, isn't it? That's our practice. That's the only homework that I'm giving you guys. I'm not, telling you turn to page 383 and work numbers 1 through 40. I'm giving y'all online practice so that you can solidify your understanding on these topics. You will not learn it successfully unless you're practicing your homework sections. And I know it sucks that y'all have two homework assignments usually, right? You got one for me and one for your math class at school. But heck, pony up and you'll be all right. Charlie, start me out with the basic here. Factor that first denominator. I say first denominator. Factor that second denominator, sorry. Good, that boy. Y minus 6, y plus 6. So the LCD, George, would be what? We want to go through and circle each new factor, raised to the highest power. So of all the denominators, y plus 6 is a new factor. Nowhere else is it raised to a higher power. Y minus 6 is a new factor. Nowhere else is it raised to a higher power. So my LCD, the tool with which I'm going to kill off all these fractions, is y plus 6 and y minus 6. In other words, that middle fraction, he's already got the LCD. This first fraction only has half of it, but that's all right. I don't really care which fractions have got what. I'm going to kill them all. Okay, it's going to be a fraction massacre. It's going to be awesome. But what we're going to do is we're going to use this LCD. We're going to multiply the top and the bottom of each fraction by it. So watch what happens. We're going to say y plus 6, y minus 6, y plus 6, y minus 6, and y plus 6, and y minus 6. Okay, and notice I had to do that on each and every term, because whatever I do, finish this statement class, whatever I do on the left side of an equation, I got to do the same exact thing on the right side of the equation. And so I can't just kill the fractions. I also have to attack that 4, okay, because he's part of this equation. So what cancels out, Quentin, on this first fraction? On this first fraction right here, what's the only thing that's going to cancel out? All right, what do you see that shows up on the top that also shows up on the bottom? Good. Y plus 6 is going to cancel out, and that's going to leave me with that original y, okay, so it's going to leave me with that original y right there, and y minus 6, but no more fraction. Okay, no more fraction. Let's see here. Jack Candiato, what's canceling out over there in that second fraction? Good, that a boy. Both of them, the whole denominator is going to cancel out, leaving me with what? 72. Okay. Okay. And then over here, there is no fraction, right? So I just FOIL it out and blah, blah, blah. That's going to be 4y squared minus 144. Okay. And again, I'll kind of highlight that's where those two terms came from. And here is where my 72 came from. Here is where my y minus 6 came from. Just to kind of color code things, you know what I'm saying? All right, so when we killed off those fractions, we were able to do so because we multiplied everything by the LCD. And then down here at the bottom, this is just now an equation that I can solve. It doesn't have any fractions in it, which is nice. What's the degree of that equation, Luke? In other words, what's the highest exponent that you see? Good. So a second degree equation, class, is going to have how many solutions? 2. That's our fundamental theorem of algebra, right? And when we'll combine like terms, sort of shuffle some things around, so we get 3y squared plus 6y minus 72 equals 0. I'll let you catch up there. We distributed, after we killed all the fractions, we had this highlighted one, the right to resulting. We distributed the y, we got these two terms. And then we combined 72 and negative 144, and we add 6y to both sides and subtract 1y squared from both sides. Combining like terms, like y'all told me to. All right, so Nate Dogg, what's my first step now? This quadratic equation, how have I taught y'all how to solve quadratics? All right, so that's a first step as far as like figuring out what method to use. And you're absolutely right that when there's a coefficient on this front that is other than 1, that's oftentimes calls for the magic method. And we could use the magic method here. However, I would caution against that because James what? There's the greatest common factor of 3. And that's going to make my job a lot easier. Always look for, what did I call those factoring techniques? The ones you look for every time? Bread and butter, baby. Bread and butter. So we're going to factor out a 3, and just actually dividing both sides by 3 would be fine by me. Give ourselves a little bit more space here. Okay, so like if I got 0 equals, now it's y squared plus 2y, 24. All right, and what is 24? 6 and 4? Y plus 6, y minus 4. Oops. So can y'all, I think I've trained y'all well enough to tell me what my two answers are. Negative 6, positive 4. Now, here's where I have to be real daggum careful. And if you did the Delta Math homework, you saw a lot of this. There's a danger that presents itself when we're working with rational equations. Rational equations are equations that have fractions. Drew Benton's going to tell us what can mess a fraction up. Very good, Drew. Absolutely right. If you didn't hear him, he spoke very softly. He said a denominator of 0. A denominator of 0 will mess your fractions up. Okay? And guess what? If I let y equal negative 6, that is going to mess up both of those fractions. It will make the first fraction be negative 6 over 0, which is undefined. It will make the second fraction 72 over 0, which again is undefined. So negative 6 is what we call an extraneous solution. Good. It's an extraneous solution. That means that I throw it out, can't use it, don't want it, no thank you. It's like an extra anus. I don't need it. Okay. So y equals 4 would be my only answer there, my only solution. Okay.
I have a question.
Now, I don't want you getting confused. We solved this quadratic equation, and we said this quadratic equation has two solutions.
but we were using this quadratic in the context of an original equation that was rational. All right, so the fundamental theorem of algebra holds. This equation right here that's highlighted, it had two solutions. The original equation from which this quadratic stemmed, the original equation is the one that had the extraneous solution that we threw out. And fundamental theorem of algebra doesn't apply to rational equations. It only applies to quadratics. So quadratic, two solutions. Yes, applying it in the context of a rational equation, we had to throw one of those answers out because in the context, it did not work. Lewis Thomas, question.
When you found like the GCF of 3.
Oh, hold on, Lewis. We got technical difficulties. I'm gonna have to change a setting, I think. It sure would be nice, Microsoft Teams, if you quit fiddling with my settings. All right, let's see if we can do this. You can do it, Coach Morgan. Display audio. All right, Lewis, let her rip.
When you found the GCF of 3 on that problem, and then you like it just disappeared. Like, where did it go?
I know, I was being hasty and I didn't write that step out. In an equation, we can do whatever we want to on the right side as long as we do it on the left side, okay? And when there is a constant GCF, I can throw it out. I can get rid of it because 0 divided by 3 is still 0, right? It's still, 0 over 3 still maintains 0, so I can still use my zero product property. And then, of course, 3 over 3 canceled out, 6 over 3 canceled down, and 72. Great question. If there had been a GCF other than 3, okay, like for example, I'm going to write up a parallel, and you guys take this down as an extra example here. If it had been something like 0 equals 3y cubed plus 6y squared minus 72y, okay? Now, Jack McBee, how many solutions does that orange equation have? It's got 3 now. It's a, what do we call a degree 3 equation? Does anybody remember? It's a cubic equation, all right? Cube, because you think of the 3-dimensional figure that's known as a cube. All right, I can divide away a GCF of 3y in this case, or excuse me, I can factor it out, and then y squared plus 2y minus 24, right? If I say, yes, I'll just divide both sides by 3y, divide by 3y. True that 0 over 3y is still 0, but that loses that answer, and I would only have two remaining answers. I think I've used the expression before, that's like throwing the baby out with the bathwater. We don't want to do that. Instead of, at this point, dividing by 3y, you could divide by 3, or you could just say, all right, since there's a variable, I'll use my zero product property at this point, and I'll say, hey, now I'm going to have my 3 answers. And what would my 3 answers be? They'd be 0, comma, -6, comma, and 4. Okay. So real good question that Lewis asked. Yes, I can divide away a constant GCF. No, I cannot divide away a variable GCF. All right, Quentin, question. Quentin, you're having trouble seeing my plus signs because of my lousy handwriting. That's a plus sign up there. You're right. If it had been a minus 4y squared, it would have been a negative 3y squared. But it's positive. So when we subtracted y squared from both sides, that's why it became 3y squared. Thank you. Anybody else? All right. Now, where are we going with all this? Okay, so over the weekend, since not everybody has done their delta math there, over the weekend, I want you to log into your delta math and practice some of these. You'll see equations that look, just like this, and you'll see a lot of equations that are easier, okay, that look more like maybe what we saw. I'm not going to have any blank examples, but yeah, more like example 1 right here, okay, from our first video, from our first screencast. You'll see some easy examples. You'll see some hard examples. And I think there's 14 in all. So it's just a normal homework assignment in length. It shouldn't take you more than about half an hour or so. But please spend some time working on it, okay? Because where are we going from here? We're going into a lesson on word problems, okay? And solving word problems using quadratics, okay? So you're going to see, how many of these word problems do I have? 7, 8, 9. We're going to have a boatload of word problems to consider. And each and every one of them is going to result in what kind of equation? The quadratic, okay? And so if I can't, go back to section 7.4, if I can't solve equations that look like, is that our only one? No, there we go, perfect. If I can't solve equations that look like this, I'm not going to be able to solve word problems that result in equations that look like this, okay? Now, I got you guys for 8 more minutes, so I'm going to put you to the task. Make you do a little bit of work for me here, okay? So I want you to look at number 214. Get a little extra practice in today. I don't think it would be wise to try and start a new topic on Friday. So we're going to keep working here with some equations. Work number 214 out. And again, follow the same steps that you and I have been talking about, okay? That involves factoring all the denominators, finding the LCD, multiplying the top of every fraction by the LCD to kill off all the fractions. And then once all the fractions are done, you'll have a resulting quadratic equation that you can solve out. And a minute ago, I feel like I misspoke. A minute ago, I said all those word problems were going to result in quadratic equations. They're going to result in rational equations. And those rational equations look like what you got on the screen here. Ben, what's your LCD? Very good. Now look, y'all are smart and y'all probably realize that on a lot of these problems, it's not
always, but quite frequently, you can use some of the problem to help you figure out what the LCD is, right? So like if I haven't worked number 216 yet, but I've got a sneaky suspicion that the LCD is y plus 1 and y minus 5. You know what I'm saying? And down here, I got a sneaky suspicion that, the LCD is m plus 5 and minus 5. So like you look at the other denominators, like this one will be 36C. That one up at the top would be s plus 7, s minus 3. Just use the problem to help you work the problem, okay? Now, if I'm going to multiply everything by that, can you, oh, man, look, I'm going to push you. I'm going to push you a little bit here. Can you figure out what would cancel out without actually writing it up every time? Like I physically have been writing the LCD at the top of every fraction, and that gets tedious. All right, so Tiago, I saw you nod your head. What cancels out on the first one, Tiago? What? The first one, the first fraction, this one right here on the left. Yeah, the whole bottom cancels out with the whole LCD. In other words, if I put W minus 7 and W minus 4 up on the top, there's a W minus 7 and a W minus 4 on the bottom that would cancel, leaving me with what? What's the only thing that I would have left? W plus 8. So I'm going to go ahead and write that up. W plus 8 on the left, okay? All right, I'm pushing you a little bit. Joe Edwards, what's going to cancel out on this middle fraction right here? And that would leave me with a 5 and a what? Good, that a boy. Okay, you see how we're being a little bit more efficient? Reed, can you do the same thing on our last fraction here? What's going to, where am I? All right, here. What's going to cancel out of that last fraction? And that's going to leave me with what? Very good. Awesome, you guys. So that's going to, hey, look, we just wrote from a rational equation. We just wrote a quadratic equation without really having to do a buttload of work, okay? That's being smarter and working efficiently. Now all I got to do, I said quadratic equation, it's really a linear equation. Excuse me for jumping the gun on that. Yeah, all we have to do is distribute these constants and then combine like terms. So it looks like 7W. And then what's 20 and 14? 34. Subtract W, add 34. And we get W equals 7. What do you think about W equals 7? It's extraneous. Why? Which fractions does it mess up? It messes up the second fraction. It also messes up the first fraction. And so we would say about this problem that it has no solution. Okay? Now that's some fine practice. We just spent 8 minutes, maybe 6 minutes, working one problem, kind of diving a little bit deeper. That's what you need to be doing this weekend. Practice. Okay? And it'll help you guys out. Lewis, question.
I forgot like how to get the LCD for problems like 218.
218. Okay, so factor each denominator. So like 12C would be 2 squared times 3 times C. 36 will be 2 squared times 3 squared. And the 4C is just 2 squared times C. And then we go through, and let me zoom in. We go through and we circle each new factor raised to the highest power. So 2 is my first new factor. Where is it raised to its highest power? It's 2 squared. I don't see anything else higher than that. One note's being silly right now. Hold on. There we go. 3 is my next new factor. It's raised to its highest power here. And then lastly, C is my next new factor, and it's raised to its highest power there. So the LCD would be the product of that, which will be 36C.
Okay.
Awesome. Good question. Hey, great job, you guys, this week. I appreciate y'all's hard work. Have a great weekend. Live Jesus in our hearts. And then I will see y'all on Monday. Thanks again.